Whatever notions, images, and expectations you may have about hydrocarbons in the 21st century, this is not your grandfather's or even your father's oil and gas industry. As with many industries of the early 20th century, drilling rigs back in the day were rather primitive affairs. Today's drilling units are a far cry from grandpa's and feature advanced technology, joystick controls, and many other features designed for efficient, safe, and environmentally responsible operations. This technology revolution has been driven in large part by the move into unconventional or shale oil and gas production, a trend that began in the early 2000s in the U.S. The tools and methods that have been developed over the past decade, pad drilling where multiple well bores are drilled from a single surface location, sophisticated seismic and three-dimensional reservoir modeling technologies that enable producers to better target the oil reservoir, and geosteering tools that help drillers stay in the sweet spot, to name just a few, have made hydrocarbon production more efficient and reduced the impact of noise and emissions on local communities. These advanced tools and techniques ensure the hydrocarbon development can be conducted in harmony with nature, agriculture, and everyday life. Most significantly, increased production of natural gas from shale in the U.S. is providing a clean alternative to carbon-intensive coal that has historically been used for electricity and home heating. In fact, in 2016, the U.S. Energy Information Agency reported that carbon dioxide emissions in 2015 were 12% below 2005 levels, primarily because of changes in the electric power grid. That's a direct result of the decreased use of coal and the increased use of natural gas for electricity generation. Shale gas and oil are produced by combining horizontal drilling and hydraulic fracturing, a technique that uses water and treated sand, or proppant, to stimulate tight rock formations. Hydraulic fracturing has been around for more than 50 years, but technological advances over the past decade have made the approach significantly greener and safer with methods that streamline the process using less equipment, more sophisticated downhole tools, cleaner chemistry, and fewer resources. Wells are fractured at depths ranging from 3,000 to 15,000 feet, while aquifers of drinking water are much, much shallower, at 200 to 300 feet or less. Also, because fractures don't extend very far upward, they come nowhere near aquifers of precious drinking water. In fact, due to the complexity of the shale rock, engineers struggled to obtain large fracture heights. Hydraulic fracturing does use significant quantities of water. The water is pumped thousands of feet below the surface under very high pressure to fracture or force open the rocks to extract oil and gas. It can take up to 5 million gallons of water to hydraulically fracture one well. While that sounds like a lot, it is minimal compared to water used in other applications. Mining, which includes all oil and gas activities, consumes less than 1.5% of all water usage in the United States, according to the U.S. Geological Survey. Further, the industry has found a variety of ways to apply the 3 R's for water: reuse, recycle, and reclaim, reducing dramatically the amount of water required for the process. This operation treats and recycles 120 barrels of water per minute.
One of the things that we've been working on that you mentioned earlier is our freshwater neutral initiative. So our freshwater neutral initiative is every gallon of water that we pump in our operations, which that includes all our operations, just not completions, we will offset that with a freshwater conservation project in that basin that we're working in. So we're not talking about drilling wells in Africa. We're talking about doing conservation projects right in Pennsylvania or Arkansas or where we operate. And we also look at items of how do we reduce the amount of fresh water by using alternative waters.
We take a lot of the water that flows back, plus some of the brine zones that are not suitable for either humans or agriculture in any fashion. In other words, the higher salinity type brines. And we take that and make fracturing fluid out of it. And in many areas, we're recycling 50 to 80% or more. And in one area of West Texas, we actually made 100% of the frack water from either produced brines or brines that could be flowed out of some of the deeper aquifers, even below fresh water. And we did not even use a barrel of fresh water to fracture with.
From major service companies to entrepreneurial startups, water treatment technologies designed to purify fracturing water for reuse are dramatically reducing the need for a continuous supply of fresh water. This minimizes truck traffic to bring water onto well sites and also reduces the need for disposal wells to store used water. Companies are even working on reclamation technologies that allow some purified frack water to be put back into reservoirs. The industry has also made meaningful strides in developing chemicals that avoid pollutants, drinking water contaminants, carcinogens, and other additives designated as toxic by the U.S. Environmental Protection Agency, while also being open and transparent about the chemicals that are used. Today, consumers can visit FracFocus, a hydraulic fracturing chemical registry website designed to provide information about chemicals used in the hydraulic fracturing of oil and gas wells, to learn about the chemicals being used, not just in general, but in a specific well. Along with water purification, greener chemicals, and sophisticated tools, the shale revolution has spawned other technological innovations that are benefiting the environment. Among them is the capture of flared natural gas at the wellhead, a breakthrough that dramatically reduces emissions while turning the gas into a usable energy, such as propane and butane for refineries. Companies like G2it, for example, capture flare gas at the wellhead and use specialized flow control, mechanical refrigeration, and compression equipment in mobile and modular gas processing units to remove natural gas liquids and condition the gas at the well site.
Yes, at our company, G2it, which stands for Gas Treatment Utilizing Innovative Technology, we specialize in the manufacture and operations of very small, modular mobile systems that go right out on the well site. We take the gas that's normally going to the flare, which is being burned off and wasted. We take that gas and divert it through our process. And that process actually goes through a proprietary flow control system. We compress the gas, we chill the gas and cool it, and when we do that, we condense out the liquids. And so we're able to take a stream of gas that would normally go into the flare that's full of a lot of liquids in addition to methane. We have ethane, propane, butane, and pentanes. We take those liquids, we're able to separate the methane portion of the stream from the liquid portion of the stream. We can take the liquids then to market, and then we can utilize the rest of the gas, the methane and the ethane portion of the gas, for beneficial use right on the well site, or we can actually compress it or liquefy it and transport it to.
Much of the captured gas is processed into compressed natural gas for use in the oil field, clean fuel for drilling rigs, hydraulic fracturing trucks, and other equipment, and for heating the water used in hydraulic fracturing operations.
Now, once the LNG, or in some cases compressed natural gas, leaves location, it can be used to help power drilling rigs, help power frac fleets, help heat frac water. Everything that you would use fuel for in the oil field, we can use that same fuel. And so now you're taking a wasted resource and turning it into a valuable one. When you consider that this gas is being burned and all the energy that's being wasted, we look at one of our single systems, which handles 1 million a day capacity. That's one of our normal size modular systems that can capture up to 14,000 tons per year of CO2 and prevent that many emissions. So every year with our current fleet, we're removing 250,000 tons of CO2 every single year just from the gas we're processing now, and we expect that to obviously to grow as we grow our fleet.
Ongoing innovation in the form of cleaner, greener technologies and a commitment to safety and transparency are redefining oil and gas production. Natural gas in particular is already proving it has a major role to play in reducing carbon emissions. This is progress, and with the abundance of natural gas resources in the U.S. and globally, this is just the beginning.